So let me quickly read through what you had sent out. So you had sent me 3 PDFs. 2 of them I could not open. It was not opening for me.
Oh.
I sent a message yesterday night, around 10 p.m. But there was a third one that I was able to open. That was around finding out sum of identities of trig functions. Okay. So that one I have handy, and that one I will go through today. And then
it's not a PDF, it's a JPEG.
Whatever be the case, it's not opening for me, okay? It's not letting me download. Yeah, it's not a PDF, it's a JPEG. When I click on that, see, this is what it's saying. Could not download document, try again. If the problem keeps happening, try turning off Wi-Fi or VPN or connecting to a different Wi-Fi network. And I turned off my Wi-Fi and then it also tried. After that only I sent a message yesterday actually. Okay?
Okay.
So it's okay. So let's do one thing. Let us go through what I can see and we will come up with our strategy for solving those problems based on what we know and what we learn and what we don't. And then whatever you have in JPEG, you will read that for me, saying, okay, this is the problem, this is what we are trying to solve. And then
the JPEG are not like problems, it's like the concepts.
Okay.
What we're supposed to learn.
Okay.
So right now, what we're supposed to learn, it's like a summary sheet that includes all of the stuff that we'll learn in this semester. And so it starts with topic 3.2, which is equivalent representations of trig functions. That's included in the PDF that I sent you.
Okay.
Along with 3.3, that I don't think 3.3 is actually included in yours, in the PDF that is actually visible for you.
Okay.
It includes trigonometry and polar coordinates, specifically focusing on like polar coordinates, because that's something new. Of course, we talked about complex plane before, and we know about that because it was one last time that we discussed about it. It's just the only different thing is the polar coordinates conversion to complex numbers and vice versa. The next page usually is not something that we have learned yet, but like I would like you to set like the base for it.
Okay.
Which is polar function graphs.
Okay.
Includes circles, roses, cardioid, dimpled cardioid, and dimples.
Okay. So let's go from the beginning and see what are the things that we need to learn. So do we know this, and then try to find out. First one says determine if the equation below are true or not. And I'm just plotting it here. It says first one is cos of 2 pi over 3 minus pi over 6 equals cos of 2 pi over 3 minus cos of pi by 6. And you have mentioned that this is not true.
Yes.
And you have to tell me why. I know you are right, but I am wanting to hear the story from you. You must be wondering, I got stuck with a storyteller.
Oh no, your camera is a little blurry, so I can't see the numbers quite clearly.
Okay, so let me do one thing. Just give me 5 seconds. It is all because of the lighting, I believe. And what I will do is I'll adjust the lighting. Can you see the board a little better? Yeah? Okay. Okay. So this was the question. I will use darker fonts. Cos of 2 pi over 3
minus pi over 6 equal to cos of 2 pi minus 2 pi over 3 minus cos of pi over 6. And is this true or not? And you said it is not true, but you have to tell me why you think so. You're talking to me, pretend.
2 pi over 3 minus pi over 6, like the number that we will get is going to be like, wait, 2 minus 2, 4 minus pi, wait, yeah, so 3 pi over 6, which is pi over 2. So pi over 2 is, the cosine of pi over 2 is not going to be equal to cosine of 2 pi divided by 3 minus cosine of pi over 6.
And this is another way of looking at it. If you remember in the previous classes, we learned about this. Cos of A minus B equals cos of A minus B. We learned this formula and we also saw how to prove it. That is, cos of A minus B equals cos of A times cos of B plus plus sine of A sine of B.
Yeah.
And if you plug, so one thing is for sure, if you have cos of one angle minus other angle, it's not equal to cos of first angle minus cos of second angle. And this goes by this formula. So just for the sake of simplicity, again, I'm not wanting you to spend too much time on this kind of questions in the exam. But if you are plugging this formula here, this becomes cos of 2 pi over 3 times cos of pi over 6 plus sine of 2 pi over 3 times sine of pi over 6. So here we don't have this thing, 2 pi over, only 2 pi over 3, we have cos of pi over 6 also, which equals pi over 6 is 30 degree, which is nothing but 1 by 2. So first term itself is not right. Correct? Now we look at this one. Sine of pi by 6 is sine 30 degree, which is cos 30 is root 3 by 2, my bad. And sine of pi by 6 is 1 by 2. By no means we see this and this being same. Yeah. Now you will say, sine, how do you say that this is not correct? Cos of sine of 2 pi over 3. 2 pi over 3. Pi over 3 is 60. 2 pi over 3 is 120 degree. If I visualize that in the unit circle, sine of 120 is here. And my y coordinate is positive only. So this whole value is positive. This value is not same as this. By no means this is agreeable. So this is another way of looking at it. And you must be thinking that I can straight away say that this is not correct. And that is true. Cos of angle A minus B is not equal to cos of A minus cos of B. That is correct. This is another way to convince yourself. You'll say, okay, I know this formula also says this. This is not really. So you have two defense which gives you a confirmation that yes, this is not true. Yeah? Okay, let's go to the next problem. And we will have a class longer than 1 hour today because I'm trying to compensate for the last week's class, which we did not have. Since you are alone here, maybe 1.5 hours would be enough, but let's see. So this is the first problem. We'll make sure that we go through each and every problem here, okay? Second problem is see again it has given the sum and difference identity is also the same PDF, right? So without looking at it, let me see if I remember the formula correctly or not. Yeah, cos of A minus B equal to cos of A cos of B plus sin of A sin of B. Okay, so yeah, I was not wrong with the formula, that is good. Now, second one says evaluate cos of pi over 12. How would you find this out? Pi over 12, I mean if you try relating that in angles, if that is much more easier. Pi is equal to 180 degrees. Pi over 12
would be 180 degree over 12, which will be 15 degrees. Yeah. And if you go back to this table that you have seen, that I have kind of bothered you guys to remember, it's sine, cos, tan, 0, 30, 45, 60, 90. Sine 0 is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. And then this whole thing repeats in the reverse order. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. I'll stop it here. So if I'm trying to find out cos of pi over 12, I'm essentially trying to find out cos of 15 degrees. And what would you do? Sorry, you finish your, sorry, you finish your, yeah.
So first of all, we're gonna find the factors of pi over 12, and that's how we learn. We're gonna find the factors, but this is where I kind of get stuck, because I can't find the factors of numbers like that.
Okay, so this is what I'll do. This might be a dirty technique because we are more comfortable seeing the numbers. Pi conversion, not everybody relates very easily. So what I'm doing is I converted this into this, and then I am relating with this table, right? I am hoping you remember these values, right? Yeah. So this value is not in this table, so we have to derive something. So 15 I can get by doing cos of 45 degree minus 30 degree. Yeah? Correct? Now, it is always up to us how we want to deal with this. I will do it behind the scene because I am more comfortable with the numbers. Okay? So let me do it this way. I have value for, so okay, if I have cos of A minus B, that is equal to cos of A times cos of B plus sine of A times sine of B.
Can I point out that like if I did this on a test, it would be like a skill 4 error. Like that would take down my marks if on the test.
But are you showing your approach for doing it, or you are only?
So there's 4 skills. One is like actual solving. 2 is forming equations and graphs and everything. Skill 3 is explaining. Skill 4 is annotation. So
Okay.
these degrees, it's gonna take down my mark.
Okay, so that's what I was saying. So if I don't have to show the approach, then this is my dirty technique. If I have to show the approach, what I will do is, I will do this calculation for myself because I as me, I get confused between pi over 12, 2 pi over 12, whatnot, right? So here, just because I know that, okay, this is 15 and 15 I can get by 45 and 30, okay? So 15 is pi over 12, that's what we have. 45 is how much? 45 degree is nothing but pi over 4 and 30 degree is nothing but pi over 6, right? So now pretending that I am super intelligent. So I will say this equals cos of pi over 12 equals cos of pi over 4 minus pi over 6. Yeah? So that means I have got, so again, this is a back end calculation we did without letting anybody know, without anybody noticing who's evaluating our papers, okay? Now, when we have this, we know this is pi over 6. In my rough sheet, right, I will just map to this, and this is pi over 4. So now this becomes cos of pi over 4 times cos of pi over 6 plus sine of pi over 4 times sine of pi over 6. Yeah? Cos of A minus B equals this. So we got cos of A cos of B plus sine of A sine of B. Now just plug in the value. Cos of pi by 4 is 1 by root 2. Cos of pi by 6 is root 3 by 2. plus sine of pi by 4 is 1 by root 2 times sine of pi by 6 is 1 by 2. So this became root 3 by 2 root 2 plus 1 by 2 root 2, which is equal to 2 root 2 is the common denominator in both of them. So root 3 plus 1 by 2 root 2. So it's very important for us to know where I have challenges. And I was shameless in saying that I get confused. Somebody says, okay, pi over 12, I would not recall it immediately. But somebody says cos 15, I would remember it. Right? So, similarly, if you look at the whole calculation also, there also you are seeing, right? I mean, I have not noticed that. It has mentioned pi over 12 is 3 pi by 12 minus 2 pi by 12. This is exactly what we got, right? I mean, so you have this option, pi over 12 is 3 pi by 12 minus 2 pi by 12. But our calculation was this. We recall this table, we know, okay, pi over 12 is 15 degree. I can get that by 45 minus 30 is 15. Same thing. They have done differently, we can do it differently. Whatever works for us. Yeah? Sounds okay? Or no? Sounds okay? Yeah. Now, let's look at another situation. This one I will not do it. I would want you to do it, but instead of focusing more on getting the answer, I would want you to narrate the story for me. It says evaluate sine of 7 pi over 12. So you have to tell me what would be your approach. And again, you can be as transparent as I was saying this would be my approach. So think about it, let me know.
Write it down, or do you want me to just verbally tell you?
Tell me, I mean, you might want to do some rough work because then only you do to talk numbers, right? I mean, don't do the final calculation, but at least break it down to a point after which it is layman's work. Yes, we do.
Sine of pi minus pi by 6.
Okay, tell me your story first.
So first I converted 7 pi over 12 into like the number, and I got 115.
Okay.
And then sine of like 180 minus 30 is 150. So
180 minus 30 is 150.
yeah.
Okay.
I'm not sure of my calculation. Give me a second.
Sure. I want you to think this better.
It was not equal to 150. It's 105. I'm so sorry.
Okay. So tell me, once you have formed up your thoughts, just tell me your story and then we will deal with it together.
I got pi over 2 plus pi 12. But like, it's not an easy conversion.
Okay. So let me do it the easy way. I mean, at least the way that I'm able to relate to.
Okay.
Again, same old dirty technique. Pi 7 pi over 12 doesn't sound very convincing. Okay, little bothersome. Let me look at how much it equals to in degree. Okay, so 7 pi over 12. 12, 15 is 180. So 15 times 7, 105. That's in degree. Okay, yeah. So 105 is a good combination of 60 and 45. Correct? 105 is 60 plus 45. And that is part of the table that we are very well conversant with. Yeah? So that's why I told you, I have been repeatedly telling this to all my kids, that your teacher is not intelligent. I have only easy ways of solving problems. Yeah? Alright? I think you don't need any other speech from me, right? You know it now. Correct? The only thing you will do is convert 60 by as pi over 6, sorry, pi over 3 and 45 as pi over 4 and you're good. Yep. just to convince people, they will do, okay, 7 pi over 12 is nothing but maybe pi minus 5 pi over 12, correct? Or 7 pi over 12 could be 3 pi over 12 plus 4 pi over 12. Yeah, and that cuts eyes for us. 3 pi over 12 plus 4 pi over 12. This 3 pi over 12 becomes pi over 4 and this becomes pi over 3. That is exactly what we need. Yeah? And then everything is straight. Okay, let's move on. So whenever you get stuck with any problem, okay, so this is the thing I have learned by being in US for some time. That if you are trying to, let's say you bought something from the store and you are trying to open it and you don't know how to open it, it's very hard. As soon as it is hard, I get to realize that, okay, in this country there is nothing hard. You are doing it wrong. So whenever you guys get stuck with the problem, what you have to remember is, my teacher did not teach me anything difficult. He is not intelligent enough to teach me anything difficult. So I'm missing on something easy. Okay? That will give you the clue. I know it's not a right example, but that is how we have to deal with it. Okay? Alright, let's move on. And of late I have been challenged by my students and parents saying that why do you call yourself the worst teacher ever? Every video of mine says it loud, that worst math teacher ever. And that's okay. Let me be the worst. Let me have the opportunity to learn things. Let's go to the next one. Alright. Now we are going to the fourth problem. Okay. Which of the following is equivalent to the expression cos of pi by 6? Let me write it down. Which of the following equation is equivalent to cos of pi by 6 times cos of pi over 16 minus sine of pi over 8 times, wait, what is this? This is pi over 8, my bad. Pi over 8 times pi over 16 minus sine of pi over 8 times sine of pi over 16. I don't know what I'm writing. So it says, which of the following is equivalent to this one? Whenever you have this question, what pops in your mind immediately?
Convert it into cosine of pi over 8 plus pi over 16, and then condense it from there.
Okay, and there's one more thing that you can think. It's cos of A times cos of B minus sine of A times sine of B. Is it relating to any of those trig identities that we have learned? So when I have cos of A plus cos of B, cos of A plus B, it becomes cos of A cos of B minus sine of A sine of B. When I have cos of A minus B, that equals cos of A cos of B plus sine of A sine of B. So this is a formula. See, whenever you see sine and cos thing coming together, okay, you have to relate it to those four trig identities that we have learned. Cos of A plus B, sine of A plus B, cos of A minus B, sine of A minus B. When you have cos together, sine together, that is a clear example of cos of A and B scenario. Be it plus or minus, that you will figure out by looking at the sign. If it's a plus scenario, your sign will be minus. If it's a minus scenario, the sign will be plus. So this is certainly cos of A plus B scenario. And this is my A, this is my B. So this is cos of pi over 8 plus pi over 16.
Yeah.
And then you multiply it by 2, multiply it by 2, and what you get? Cos of 2 pi over 16 plus pi over 16. This became cos of, your denominator is same, 2 pi plus pi, 3 pi over 16. That's it. And you have one of the answers there. So, this
Pi over 6.
I'm sorry, what?
So cosine of 3 pi over 16 is pi over 6, and then cosine of
No, this is not.
No?
This is not 3 by 16 is not pi over 6. 3 by 18 would be pi over 6.
Mm,
Yeah? So, and let's see, we have one of the options. Yes, the option C was 3 pi over 16.
mhm.
Yeah? So again, there's nothing fancy about it. Only thing is, we have to get our approach first. This will be your key. Yep. If I have to tell that does Vedansi know the concepts, I have zero doubt in my mind. You are, again, I'm saying this on purpose. You are one of my brightest students. I have no doubt in my mind. Okay? So, do you know the concept? You are better than many of the kids in the class. Not only this class, I'm talking about the kids who are doing pre-calculus with me, kids who are doing SAT with me. Okay? Where you will score is here. This is what will give you the right direction, right approach, right way to cut down on the wastage of time during the exam. Okay? So essentially, I mean, sorry if I'm going for a speech, but my point is, when you have a problem like this, your initial 10 seconds are crucial. Okay? When you are wrapping your head around, how am I going to solve this? Am I going to convert this into some angle, then do it, and then do the calculation? Or this is giving me a clue. Again, going back to the same example that I was giving you, right? If you buy a can from Walmart and then you are struggling to solve it, to open it, that means you are probably going the wrong path. You have to decode your path in the beginning and then you will find. Okay? Alright. Let's go to the next one. I hope there is nothing more in this particular problem to explain, right, Nancy?
Yeah.
Okay. And this is the reason why I'm still with this subject at this age. Okay. Everything else I learned at your age, I don't think anything is carrying with me any further. Because those were subjects which I could not relate to. Or there were a lot of assumptions made. Here in maths, there is no assumption. Now, this one I will not solve, I promise. And I guarantee you will be able to solve it by applying your RAND and some dirty techniques that I keep teaching you guys. So it's sine pi over 12 times cos pi over 12 plus cos pi over 12 times sine pi over 12. Sine 5 pi over 12 times cos pi over 12 plus cos 5 pi over 12 times sine pi over 12, and you have to find out the value of this.
So this is the sine of A plus B. And sine of 5 pi over 12 plus pi over 12 is 6 pi over 12, which simplifies to pi over 2, and sine of pi over 2 is 1.
How much time did you take? 30 seconds? See? So, the 10 seconds that you invested to think about it is where the magic lies. Okay? If you always had the option of converting this to angle. Nobody is stopping us from doing that. But that will be an overtime. Yeah? You have much smarter ways to solve it. So, see, you are making me speechless. Let me go to the next one. Now, these are the one. Okay, this is an interesting one. And again, interesting, but I did not say difficult, okay? It's about how we think about it. This problem says sine of x plus y minus sine of x cos y divided by sine y. This is the expression that we have. Okay? You can call it rational expression, whatever you want to call it. It says rewrite this into an equivalent expression only in terms of cos of x. Sine of x plus y minus sine of x cos of y divided by sine of y. Rewrite this in terms of cos of x. Expression only in terms of cos of x. And if I were you, I would have started wondering, I have sine of x plus y. Somebody is asking me to, I have x and y both the angles. It says write only in terms of cos of x. Where does y go? And where would y go? But that is only to create confusion. I'm saying, how would you approach this problem? First tell me your thought process, because you know Hindi, right? I used some word in Hindi in between. I said, uske baad we will talk about it. Okay, so give me your thought process first, and then.
I was thinking of simplifying sine of x plus y. So we get sine of cosine, sine of x times cosine of y, and then the one for the formula, the trigonometric identity. Then factoring all the cosines out and sines out. Then we can divide the sign with the one in the bottom.
And you are thinking in the right direction. I have zero doubt about you struggling with this, but it's going to be much easier than what you thought. Just do it. Let's see. It's going to be easier than that. But you are thinking the right direction. You know, nothing wrong with your approach. Okay, it's going to take less time than you thought. Okay, trust me.
So we can do sine of x plus y divided by sine of y, and this.
No, don't do that. Just expand it first. Just expand it and see what happens.
Oh, it's just cosine of x. It's all simple.
Yeah, that's what I'm saying. So there's a saying in Hindi which says, "मैंने धूप में बाल सफेद नहीं किए हैं." I did not solve this problem, honestly speaking. I started looking at this one yesterday night around 10 o'clock, and I did not have patience to look at it. But as soon as I see this problem, right, it gives me a hunch. Sin of x plus y, no, sin x cos y, cos x sin y. And sin x cos y will be gone here. And from this one, sin cos x sin y, this y will be killing that sin y. So I'll be left with only cos y, cos x, sorry. So just for the sake of simplicity, that's what I'm saying, that you are going the right direction, you are breaking it down. And I actually purposefully confused you, saying that this is easier than what you're thinking. But I made a statement that you are in the right direction. So you have to break it down. Let's see. See, if you know the identity already, just expanding it doesn't take more than 30 seconds. So you know, okay, fine. Sin x cos y plus cos of x sin of y. And then you have this one as minus sin of x cos of y. As soon as you see this one, you would see that sin x cos of y, these two are eliminating each other. Then you are only left with this. These two are getting also cancelled out. You don't need to do any calculation actually. Yeah? So, nothing difficult we have done so far, thankfully. Because if you give me something difficult to deal with, I will get stuck. And Vedansi is waiting for the day when she will get me stuck saying, okay, this teacher doesn't know beyond this. But you know what? I will get stuck as a teacher, but there is a student who is still alive in me. I will learn it and come back to you. Okay? Because I love this subject. I don't know why.
Honestly speaking, you will have way more opportunities to learn, teach me this. Because, like, my teacher is very often absent, and so for some reason, she always schedules her meetings during our classes.
Okay.
So, you will have a lot of opportunities.
Okay. Okay, that's fine. So see again, I mean it's all about how do you approach things, right? I mean if I get stressed out by seeing a problem, that is why I have devised this technique for myself and for all my kids. I had a letter T also in the beginning, which I eliminated, okay? That T was for trust. And if I have a problem to solve, let me read it once, twice, thrice and see what exactly is there to be solved. So reading helps me to a great extent. Then I will start thinking about it. Okay, the other things I know, the other things I can do. Maybe this is a better option. And then I'll come here. I might go wrong with my analysis. There's a possibility. But then at least I have explored all the options. And it might so happen that after doing the analysis, I would realize, oh, this is the concept I've not learned even. And that's okay. That is when the student within me will wake up and learn it. But this at least gives you a very thoughtful approach. That's why I keep bugging you guys with this recommendation. Okay? Alright, let's look at the last problem. Oh, no, this is not the last problem. We have many more. Next one is, the figure shows two circles centered at the origin with angles measuring alpha and beta respectively in standard positions. The terminal ray of angle A intersects the circle at point B and the terminal ray of angle beta intersects the circle at point Q. The coordinates of P are this and the coordinates of Q are this. It is just trying to confuse with an unsuccessful attempt. Okay, there's no big deal about it. This is where my magic of reading the question will simplify it. Okay, not my magic, it's our magic now. Okay, I'm reading this question. There are two circles, this one and this one. Okay, the figure shows two circles centered at origin with angles, this shows alpha and beta. So this is a circle and this point P with the coordinates -5, 11, square root 11. This
The camera is getting blurry again.
getting blurry. Let me see if I can slightly better. No. Slightly better? No? Okay. I will read it for you so that way it becomes easier. When I have the lights on, that is when. Okay, let me do one thing. Let me open the door. It might make it better. So this is the angle alpha and this circle, this point has a coordinate of 6, 0. This point has a coordinate of -5, square root 11. This one, this angle is beta and this point has a coordinate of 2, square root 5 and this point has a coordinate of 3, 0. Okay. So there are two circles. Here this circle 6, 0. Okay. And this angle is alpha and this point is -5, square root 11. In this circle this angle is beta So beta is the angle made by with the positive axis. And this point's coordinate is 3, 0. Okay. The terminal ray of angle alpha intersects at point P. Terminal ray of angle alpha intersects at point P with the coordinates minus 5, square root 11. And the coordinates of Q are 2, square root 5. Now it says find sine of alpha plus beta. Yeah. While it might look like a difficult question, but it's an easy one. Think about it. Tell me. Yeah.
So first we know like what do you call it? The radius is 6 for the one with alpha, and the radius is 3 with this one.
But beta.
First we need to have same radius that have same angle measures. So it's either that we convert it to unit circle, or we can just divide the one with 6 radius into 2 to get the thing.
Yeah.
Then we'll have to expand this one because we have the values, and so we will get sine of alpha times cosine of beta plus sine of cosine of alpha times sine of beta, and then get the answers through that.
Exactly, and you're on the right path. While by seeing these pictures, kids will get scared. I can guarantee you, catch hold of any of your classmates and ask to solve this problem, they will overthink about it. Trust me. Yeah. Here we are relating this with unit circle. If this was a unit circle, meaning if my radius was 1, then my coordinates would have been, this x coordinate would have been cos of alpha and sine of alpha. Here same thing. If this would have been a unit circle, this would have been cos of beta, sine of beta. But here the radius is 6. So whatever coordinates we are seeing, that is 6 times of what would be my cos of alpha or sine alpha beta value. Similarly, whatever you are seeing here, that would have been, if this was a unit circle, that would have been 1/3 of what you are seeing now. So basically this gives you cos of alpha equal to whatever you see here minus 5, divide that by the radius. Sine of alpha would be nothing but whatever you see here square root 11 divide by 6. Similarly here cos of beta would be whatever you see divide that by 3. Sine of beta would be nothing but whatever you see divide that by 3. And you already know this, sine of alpha plus beta equal to sine of alpha times cos of beta plus cos of alpha times sine of beta. And you have all the values here to plug it. Yep. So, see, this is where you have to get little, what do you call, just try to look for the right word, little nosy with some of your friends. Catch hold of one of your friends and see, if you have this problem to solve, how do you go about it? See, there is no mischievous intent. What we are trying to do is, you will ask your friends to say, okay, if you have a problem like this, how do you solve it? Your friend might surrender and say, oh, I don't know. Then you will tell this approach. If your friend knows, then, and he or she does in a different way, you have an opportunity to learn something, right? And then you can evaluate, okay, whether that approach is faster or this approach is faster. Okay, so this is what I keep enthusing all my kids to share what you know, because when you have learned this, when you explain this to your friend who doesn't know about it, that concept will become yours forever. That will get glued with you actually. That is the intent. Okay, so try doing that trick and see if that works. Okay, because I had a cousin who was like 6 months elder to me when I was your age, and he was 1 year senior in the school, I used to study and I will try memorizing things if I don't understand. He will say, no, don't do that. If you learn something, can you explain that to somebody? And that is when I realized at a very young age that, yeah, if I'm able to explain what I learned, that becomes much more solid with me. Okay, let's move on. So all these, extra gyan that you get, that is free. I know that gets a little annoying for kids, but you know what? There has to be some emotion with whatever we learn, right? Otherwise, I don't want to sound like a robot to you. This has to be something that we relate. Yeah? Now, next problem. Use the sum difference identity to simplify cos of pi by 2 minus theta. I'm not going to do it. It says sum or difference identity that you know to find out value of cos of pi by 2 minus theta. It's easy peasy, right? Nothing difficult. Cos of a minus b is equal to cos of a times cos of b plus sin of a times sin of b. See this. I am not doing it. There is a reason, because I see that there will be one value which will have cos of pi by 2, which is 0. I can really skip that part. And there will be one value which will have sin of pi by 2, that is also 1. Look at this. This cos pi by 2 minus theta is nothing but cos of a minus b. Cos of a times cos of b plus sin of a times sin of b. This one becomes 0 because you have a cos of pi by 2. This is 1. So this you are left with sin of theta times 1. This is also called the theorem of complementary angles. Remember? Okay, let me. So this is the last thing that we'll do. Okay, I don't want to get you stressed out by hearing my boring speech over and over again for so long, and that to being alone. If Arus was there, part of my energy would have got diverted to him also. He is not here today. So okay, so this is called the theorem of complementary angles. Now look at this. This is your right angle triangle. This is theta. Okay. This is 90 degree. Okay. SOHCAHTOA tells you, let's say this is A, this is B, and this is C. SOHCAHTOA tells you sine of theta equal to A by C. Cos of theta equal to adjacent side by hypotenuse, that is B by C. Okay. If this is theta, how much is this one?
Pi minus theta.
Pi by 2 minus theta, 90 degree minus theta, whatever you call it. Yeah. I'm just using angles right now. Just to, we'll relate to pi by 2 at later point in time. So this is 90 degree minus theta. If I look at this triangle from this view, meaning I'm using this as my angle. So cos of 90 degree minus theta, meaning when I'm keeping this angle in focus, this is my adjacent side, this is my opposite side. So cos of 90 degree minus theta will be equal to A over C, adjacent side over hypotenuse, which is same as, this is called the rule of the theorem of complementary angles. So sine of theta is equal to cos of 90 degree minus theta, or vice versa. Here in this case, if you are talking about sine of 90 degree minus theta. So this is my angle, opposite side would be this, which will be B over hypotenuse, which is C. This again matches with this. So this is the theorem of complementary angles, meaning sine of a theta is equal to cos of 90 degree minus that theta. Cos of theta is equal to sine of 90 degree minus theta. So let's say if you are given cos of 12 degree equal to some value, okay, random value, let's say 0.6, I'm just making it up. And you are asked to find out what is the value of sine 78 degrees. you will not even think about it. You will not even take your calculator out because you know these two are complementary angles. So cos of the angle would be equal to the complementary angle of sine of that. You will say it will also be the same thing. Cos of 12 degree equal to sine of 90 minus 12 degrees. 90 minus 12 is 70, that's what I was saying. Make sense? 100%?
Yeah.
Enjoy the rest of the day. Okay? Alright? But before you go, what I would request you is, we still have few more problems in the same sheet, okay? That's the PDF that you have sent. I just want you to skim through those problems and tell me if there is something that is still getting a little worried from an approach point of view, okay? And if it does, we are meeting again next week. Yeah?
Yes. But next week, could you discuss about the polar coordinates?
100%.
I would send a different picture this time.
Exactly. But polar coordinates, let me spend 5 minutes here
Okay.
to relate it, okay? These are all the same thing with different packaging, okay? There are different ways of looking at it. We have seen x, y, theta kind of thing when we look at the two-dimensional stuff. This is your x-axis, this is your y-axis, and okay, if I am picking a point on a unit circle, this is the angle theta I am making. So you are able to say that, okay, my x and y coordinates here, my x and y coordinates here are cos of theta, sine of theta. Yeah, it's a unit circle. Imagine this was not a unit circle. And this was a radius, something, 2, 5, 10, 20, 100, whatever it is. And you picked a point here. Okay? When you drop a perpendicular and visualize this as a right angle triangle, what will be the value of this side?
R times sine of.
R times sine of theta.
Yeah.
And what is the value of this side?
R times cosine of theta.
R times cosine of theta. Okay? So you will say it's R times cosine of theta, comma, R times sine of theta.
Yes.
If you are trying to locate a point, you are realizing that if you know the radius and the angle it makes with the origin against the positive x-axis, that is enough for you to locate a point. Let's say this is the coordinate plane. If I am talking about this point, what all constitutes this point? The x coordinate and the y coordinate. That is one way of looking at it. This is the Cartesian coordinates. Now we are saying this is another way we can look at it. We can look at this point. We can join this with the origin. Okay? The distance and the angle that it makes with the x-axis. The theta. So this is the radius or the absolute distance with the origin and the angle it makes with the positive x-axis. This is enough because you will say, okay, fine, if this is r and this is theta, the coordinates will be r cos theta, comma r sin theta.
Yeah.
So this is the basic premise of a polar coordinate. It says that you don't have to worry about x and y coordinate values. If you know the absolute distance between the point and the origin of the coordinate plane and the angle that it makes with the positive x-axis. It's the same thing in a different package, okay? We'll go into that and we'll deal with it. So here it's called Cartesian coordinates, x value, y value. Here it's called the absolute distance and the angle. It's called polar coordinates. That's what I remember without having gone through it. You send me those sheets. I will make sure that I'm not bluffing or I'm not giving you anything which is not supposed to be right. Yeah?
Okay.
But will that be late or will it be okay if you do it next week?
It's gonna be okay.
It's going to be okay? Yeah.
We still have
Oh, not December. We are not going that far.
No, Saturday, like the test.
Okay. When is the test?
Might be, wait, we'll have to check.
Okay. So just check it, and if it's coming earlier than that, let me know. Then I would pick up this topic in the next pre-calculus class, which is on Wednesday, and I would request you to join if you can. So I mean, if the test is so coming so very close, okay?
We have not completed the entire topic yet. Like
Oh,
we
then-
have not touched the polar graphs yet.
Then you don't have to juggle with this. Yeah.
Yeah.
Yeah. Okay. Then send me those questions and all. This was just a prelude. You can even ignore what I said. We will come to this. Okay.
Okay.
All right. Yeah.
Okay.
Take care. Bye.
Bye.